Hello, good day everyone. Before we begin our session on basic oil well intervention on Wellsite Slickline operations, let's quickly remind ourselves of safety. Even though this is an online presentation, the subject we are discussing involves high-risk field activities which would make us to adopt the following philosophy. 1. Respect for operations. Slickline work involves live wells, pressure and heavy equipment. Always remember the hazards when applying this knowledge in the field. Number 2, personal safety first. In actual operations, personal protective equipment such as hats, gloves, and goggles and protective clothing are non-negotiable. Number 3, equipment integrity. Tools and pressure control equipment must always be inspected and function tested before deploying to the field. Communication. Number 4, clear instructions and teamwork prevent incidents both during learning and in the field. Number 5, stop work authority, whether in training or on site. If something doesn't look right, stop and clarify before proceeding. Our goal today is to learn safely so that we can apply this knowledge effectively and responsibly in the field. Safety is always the first priority. Let's get started. Once more, I will say welcome everybody to today's session on basic oil well intervention on Wellsite Slickline operations. My name is Benjamin, and I'm a well intervention specialist, a consultant, and also the managing director of Evu Oil Well Services Nigeria Limited. In this lecture, we'll focus on the role of Slickline in well site activities, the tools used, the operational processes, and the safety practices that make these jobs successful. Slickline operations are among the most common well interventions in the oil and gas industry, so understanding them is essential for your technical development. What are the learning objectives of this lecture? By the end of this session, you should be able to explain what Slickline operations are and why they are important in well intervention. Number 2, identify the key tools used in Slickline jobs and their applications. Number 3, describe the process of assembling a Slickline tool string. Number 4, understand the safety measures and procedures required for Slickline work at the well site. And number 5, apply this knowledge to practical scenarios through examples. Introduction to oil well intervention. Well intervention refers to any operation carried out on an oil or gas well during its productive life to improve or restore production. Without intervention, many wells would quickly lose efficiency. Interventions can range from very simple slickline runs to complex coil tubing or hydraulic workover. Slickline is usually the starting point because it is efficient, cost-effective, versatile, and small footprint. What is Slickline then? What is Slickline? Slickline is a single strand wire run into the well using a Slickline unit, primarily to set, retrieve, or manipulate downhole devices. Unlike electric line, Slickline has no conductor. It is purely mechanical. It is used with specialized tools attached at the end of the line, collectively known as the tool string. This makes Slickline a fast and economical way to perform many downhole tasks. I've seen a lot of people, they confuse Slickline for wireline, but no, there is a difference between the two. One has a conductor that runs through it, which is the wireline or electric line, while the other one is a single line that has no conductor that runs through it. Take note of it. Slickline equipment at the Wellsite. What do we mean by this? At the Wellsite, a Slickline operation requires several pieces of equipment. One on the list is the Slickline unit itself. This unit houses the drum, wire, and control system. We also have the pressure control equipment. This includes the lubricator, the stuffing box, and the blowout preventer, otherwise known as BOP. Then the tool string. The tool string comprises the tools attached to the wire. We have the measuring head. Measuring head records depth and line movement. Each of these play a role in ensuring smooth and safe operations during Slickline operation. Common Slickline tools. Pay attention to this is important because a lot of people do fail when they ask them about these Slickline tools. What are the Slickline tools? Here. The tools are the heart of Slickline operations. We do categorize them into 1. The pulling tools. These are used to retrieve plugs, locks, and valves. 2. The running tools. These are used to set downhole devices like plugs and mandrels. 3. The shifting tools. These are used to open or close sliding sleeves in the well. Then the fishing tools. These are used to recover stock or lost equipment. Selecting the correct tool is critical for success and safety. Application of Slickline operations. Slickline operations cover a wide range of applications such as setting and retrieving plugs for zonal isolation, shifting sliding sleeves for production control, deploying and retrieving gas lift valves, removing sand or scale bridges with balers, fishing for stock or drop tools. Because Slickline is simple yet flexible, it's often the first intervention technique chosen. Then let's talk about the tool string assembly. The tool string assembly is built in a specific sequence to achieve the job. A typical sequence may be: first, the rope socket, followed by the stem, which is the weight bar, then the jar, before you now have the service tool. In some of the classes I've anchored, I explain this in real details, but for the benefit of this class, I'll still talk more on it. The rope socket connects the line to the two-string. It is the bridge between the Slickline and the remaining two-string. The stem provides weight. The jar delivers impact, and the service tube performs the actual job according to the Slickline program design, like the pulling or shifting. A correct assembly ensures tools operate effectively downhole. When I come to the pressure control equipment, working on live wells requires strict pressure control. The main components are the stuffing box. The stuffing box seals around the Slickline to prevent gas leaks during operations. We have the lubricator. The lubricator is a long pressure-tight tube housing that houses the two-string before entry. Then they have in the BOP, the blowout preventer. This provides emergency sealing capability if needed. These components prevent uncontrolled release of well fluids, ensuring safety of personnel and the environment. Redress of Slickline tools. I've also still emphasized on this. After every run, tools must be redressed. Redressing means inspecting, cleaning, and replacing worn parts, such as dogs, springs, hairpins, or even keys. For example, if a pulling tool is not redressed, its dog may fail to latch, causing a misrun. A well-maintained tool string ensures reliability and prevents unnecessary fishing operations. Safety in Slickline operations. Slickline work is performed under pressure, often with hydrocarbons flowing. Safety cannot be compromised at this point. Key practices include proper PPE at all times. I remember there was a site in Nigeria, precisely in the Niger Delta, and to be more specific, at Uzere. I saw some personnel, they were not even putting on PPEs. I stopped the job and I called on the attention of the company rep for him to have allowed this kind of personnel to be on site. At the end of the day, we discussed about the safety implication and he agreed. He thanked me for it and they normalized what should be by everybody being on PP before the job continued. The other practice, barrier management. Always maintain at least 2 pressure barriers. Clear communication between crew members. Strict adherence to redress and inspection routines. Safety is everyone's responsibility, and a lapse can cost lives and production. Wellsite crew rules. Wellsite crew rules. Here comes a very critical key aspect regarding Slickline crew and responsibilities. A Slickline crew typically includes 1. Supervisor. The supervisor plans and directs the operations. 2. Operator. Operator runs the Slickline unit. 3. Assistant operator. Helps in rig up, handling tools, and safety checks. Then 4. The company rep, otherwise known as the company man. He represents the operator or the client at the site. Understanding such role ensures teamwork and accountability. Graduate training learning focus. If you are still in school, going through this lecture, pay attention. Or you just graduated, equally still pay attention. As trainees, your key learning goals during Slickline exposures are: 1. Learn to identify different Slickline tools. Take note of this. Participate in assembling a tool string under supervision. Observe pressure control rig up and understand its function. Take part in tool redress and record findings. Hands-on learning is the fastest way to build competence. Practical demonstration activities. On this slide 15, it is more of a practical session. If you are in any way close to where I am, for those that know me, or any company that has well intervention as their product lines, meet them, negotiate with them, and arrange a premises for you to have a hands-on experience, because in this week you will engage in supervised practice sessions, including visual identification of pulling, running, and shifting tools, the step-by-step assembly of a Slickline tool string. Some of us that are listening to this lecture have passed through this phase. For those that have not been privileged, you can contact me on my direct line to arrange a space or an environment for you to have the hands-on practice. My WhatsApp line is 070 111 333 05, and my name is Benjamin. The practical demonstration also involves simulated redress of tools after use, observation of pressure control equipment function. These activities bridge theory and real-world applications. The expected competence by end of this training. By the end of this session, you should be able to identify the most common Slickline tools, explain their functions clearly, assemble a basic tool string correctly, understand how pressure control equipment protects Wellsite safety, demonstrate redress procedures under supervision. We've been talking about how we maintain our tools the moment they come back from the field. This case study is something similar to deviation from the practice. So let's give attention to this particular case study. Let me give you a practical case study on an improper redress of a grip and shear pulling tool, GS. That's what it means. A GS pulling tool was improperly redressed after multiple runs. The dogs failed to latch when deployed in the well, leaving the plugs unretrieved. The result was a costly fishing operation that delayed production. Lesson learned: never skip redress and inspection. A small oversight can escalate into a big operational challenge. I know many of you don't know the meaning of GS, pulling tool. Well, GS stands for, like I said before, grip shear pulling tool. Grip shear, that's the meaning of GS. Let me go a little bit into the case study proper. Give me your rapt attention here. During a well intervention operation, a GS pulling tool was deployed to retrieve a downhole plug. The operation was expected to be routine, but complications arose due to improper redressing of the tool, that is the pulling tool. What now happened? The GS pulling tool was run into the well bore with the intent of latching onto the set plug. However, once at depth, the tool's dogs failed to latch properly onto the plug. Despite repeated attempts, the plug could not be retrieved. As a result, a fishing operation became necessary, significantly extending operation time and increasing well intervention costs. It's not good. And why did this happen? After investigation, a post-job investigation revealed that the pulling tool had been improperly redressed prior to deployment. Specifically, the dogs were not correctly inspected for wear and tear. Assembly procedures were not strictly followed. Quality checks were not documented before the tool was sent to the field. This improper redress directly contributed to the failure of the dogs to latch onto the plug. What was the consequences therefore? Operational downtime, which no asset owner wants to hear. If you have so much downtime, they will just evacuate you from the site as a contractor. The retrieval failure led to unexpected fishing operations, increasing rig time, increased costs, additional equipment and personnel were required for the fishing job. Reputational impact, trust in tool readiness and maintenance reliability was questioned about the company that was carrying out this Slickline operation. What would have been the correct, what is the learning point? What did we have to do to correct these actions? Redress protocol enforcement. Standardized and documented procedures for redressing GS pulling tools must be strictly adhered to. Inspection of and quality control. Implement a double check system where tools are inspected and signed off by two separate technicians before deployment. That's QAQC. Training and competence, like what we're all going through at the moment. Ensure all personnel involved in tool redress are trained on failure modes and the importance of proper assembly. Preventive maintenance records. Maintain detailed records of tool usage, redressing, and inspection for traceability. The lessons learned, therefore, is this. This incident highlights the critical importance of proper redressing and inspection of downhole tools. Even routine operations can fail when preventive measures are overlooked. A disciplined approach to tool preparation not only ensures efficiency but also prevents costly downtime and fishing operations. What are we to take home from this case study? The failure of the GS pulling tool due to improper redress served as a reminder that attention to detail in tool preparation is essential in well intervention. By reinforcing procedures, inspections, and training, similar incidents can be avoided, safeguarded both time and resources. As a recap, let's recap what we've covered. Slickline is a mechanical wire line used for setting, retrieving, and shifting tools. Key equipment: Slickline unit, tool string, pressure control equipment. Tools are grouped into pulling, running, shifting, and fishing types. Safety and redress are central to Slickline reliability. This forms the foundation of your practical competence in Wellsite Slickline work. In conclusion, Slickline operations form the backbone of routine well interventions. They are simple yet powerful in maintaining well productivity. Success depends on the right tool selection, proper tool string, assembly, effective pressure control, and rigorous safety practices. As trainees, your commitments to learning these fundamentals will prepare you for real-world operations and career advancements in the oil field. Can I say thank you for your attention, and God bless you all.